Okay, the dreaded work problem. In these particular problems, we have two people, or maybe more, working together to complete some task. In this specific example, we've got somebody that can wash a car in 8 minutes and somebody that can wash a car in 6 minutes. And then we want to know how long will it take the two of them working together to wash 7 cars. Now, the very common mistake people make with this is they think, oh, it's just an average problem. This guy takes 8 minutes, this guy takes 6 minutes, so their average is 7 minutes per car. On an average of 7 minutes per car times 7 cars, that's going to be 49 minutes to do the job. But as you can see here, it's not 49 minutes. These are not an average problem, and they're kind of easy to figure out why that's not going to make sense. For example, take this guy that can wash the cars fastest. It takes him 6 minutes to wash a car. So if he's washing a car in 6 minutes, him working by himself to wash 7 cars would only take him 42 minutes if he's working all alone. Saying that together they're going to take 49 minutes, which is longer than it would take him working alone, doesn't make sense, assuming they're not goofing around and such. So averages are not the way to do these problems. Instead, the way to set these up is we're going to have to set up a rate. So for example, we have one guy that can wash 1 car in 8 minutes. I'm going to leave my label off just so this doesn't get too messy, but that's my rate, 1 car per 8 minutes. I'm going to multiply that by the time it's going to take him to wash all 7 cars, which I don't know, so I'm going to use a variable. In addition to that though, so plus, I've got somebody helping out. Their rate is that they can wash 1 car per 6 minutes, and again, it's the rate times the time it's going to take them to do it, which I don't know, but I know it's the same as the other guy's time. I'm going to set that equal to the number of cars I want to wash all together, which is 7. Now I want to go ahead and solve this equation. Even though these are fractions right here, they're still like terms. They have the same variable in them. So I can add 1/8 and 1/6 together to get 7 over 24. Now if you're not good with adding fractions or have no idea where I got that from, I found a least common denominator. I did all that. If you don't want to do that or don't remember how to do it, then I guess just use a calculator for now. We'll come back to that idea later in the year. But 1/8 plus 1/6 is just 7/24 times time, and then equal again to the number of cars I want to wash, which is 7. At this point I can either divide, or what I'd prefer to do is probably multiply by the reciprocal to get rid of that fraction. So I'm going to multiply both sides by 27 over 4. And once I do that, I find the time that it would take them working together to be 24 minutes, much quicker than even the quickest guy working by himself. Remember that we said the guy working by himself would take 42 minutes. That's why the 49 didn't make sense. He's not going to slow down. But working together, I found out 24 minutes is going to be how long it takes them. Again, the key is to use rates to set these up. Do not try to find average. That is not how these problems work.